Hey guys, welcome back to our channel Get Play Soon. In this video, we are going to discuss process in operating system. This is the sixth video in the series of operating system. If you haven't watched the previous videos yet, then make sure you watch it. Now let's get started with today's video. What is process? In order to understand what is process, first you need to understand what is program. A program is a set of instructions that perform a specific task. So a program is nothing but the code you write. The set of instructions is literally the set of lines you write. Right? When you write a program and when you execute it, you will get the output. So to perform that specific task, you write the instructions in such a way. Okay. The programs are written in high level programming languages like C, C++, Java, Python, etc. When you write this high level code, this is not understandable by machines, right? So this high level code is then converted into machine level code by passing it through compilers or interpreters. Then it is turned into machine level code and the system can execute it. So this is what a program is. Simply a program is a set of instructions that performs a specific task. Even more simpler, a program is nothing but the code you write for something. Moving ahead, now let's understand what is process. A process is an active instance of a program in execution. Let's first understand program in execution. After writing the code, after compiler, interpreter, and then after shifting it to the machine level code, whatever code you have written, it is executed. This process of program in execution is known as process. Now we are calling it as active instance. This means the current state of the program. Okay. So the process represents the current state of the program when it is loaded into the computer's memory. So basically when it is in execution, we call it as process. Moving ahead, when a program is loaded into memory and executed, so when you write and save the file and it is executed, it becomes a process. Now you might have understood what is a process. Now moving ahead, a single program can create multiple processes, each running independently of the others. Now let's look at this. You write a code, it is one program, so it is one code, one program. Now you can create multiple processes of single program. For example, if you open Microsoft Word, you take two Word files. In one, you are writing about one project. In other Word, you are writing the other project. So the process of opening the Word, creating a Word file, everything is same. That is single program. Now these two Word files are different from each other. They run and work independently of each other. Two different Word files. So a single program can create multiple processes and each of them is independent of the others. As I said, there is no connection between the two word files. Moving ahead, processes have their own memory space, resources, and execution context. So, from one program, you will get multiple processors, right? In each process, have their own memory space. In one word file, if I write 20 lines, in the other word file, I write 500 lines. So, their memory is different, right? So, each process have their own memory space, own resources, own execution context. About this, we will also look in the next slide. So, please stay tuned. Moving ahead, the operating system manages and schedules processes, ensuring they can run concurrently on a computer system. So, as you can see, OS is responsible for controlling the execution of processes. It allocates resources, it manages memory, it ensures that process can run concurrently. So, as you can see, the OS is responsible for the execution of processes. It gives everything. The operating system manages and schedules processes. It ensures they can run concurrently, which means there is no disturbance. A multiple process can run at a time without any problems. It also says which process gets the use of CPU at given particular time. It is also responsible between the CPU switching. It also decides which process gets to use the CPU at given time. So all these things is managed by operating system. We'll also look about this in the upcoming slides and upcoming videos. So please stay tuned. So this is what we have learned about process. In short, a process is program in execution. OS takes a very good responsibility of processes in execution, and from single program we can create multiple processes, and each processes have their own memory space and resources. So this is process. I hope you understood what is process and what is program. Moving ahead, Let's see the differences between program and process. A program, as you already know, a set of instructions written to complete the task. On this side, process is an instance of executing program. In short, a process is nothing but a program in execution. Moving ahead, program has longer lifespan than process. Why do I say this? Once you write the code and you saved it in a file, nothing is happening. Until you delete it, it has a longer lifespan, right? But coming to the process, only the execution time is the lifespan of a process. Once the execution is completed, the process is terminated, right? So the lifespan of the process is very less when compared to the program. Moving ahead, when you write a couple of lines, when you write the program, it only needs to be saved in some particular memory, right? So there is no resource requirement. We don't need to use any CPU functions to save the file. All we are doing is writing the code and saving the file. So we are not using any resources in program. But when it comes to process, during execution, we need CPU, we need memory, we need input output, we need high resource requirement. So program has no use of resource requirement while process has high resource requirement. Moving ahead, program is static entity while process is dynamic entity. Why I call program is static entity is because it remains unchanged over time. Once you write the code and you hit that save button, it is same similar, but during execution, you might take input, you might take output, or you might do any other thing. It is actively executing. While executing, it means it can change the state during the lifetime, right? So that's why the process is known as dynamic entity. So these are the four differences of program and process. Very important question you might face in interviews or in your placement, MCQs, etc. Moving ahead, now let's understand how the process is inside memory, right? Process is nothing but a program in execution, while execution, how the memory is stored, how the process, how everything is working. Now let's understand. There are four major components, that is stack, heap, data, and text. Let's start from the stack. Let's understand how these four components are placed and designed. The first thing is stack memory. A stack memory is used for storing local variables, function call information, and the execution flow of the process. So if there is anything you need to enter into the memory or anything you need to pop out from the memory or remove from the memory, as you already know, the stack data structure works in last in first out or first in last out way. Okay, you need to push the item or you need to pop the item. So this is how stack memory works. What are we storing? Like local variables, function calls, and execution flow, right? This is stack memory. Moving ahead, we have heap memory. Unlike stack memory, what are we storing in heap memory? In heap memory, we are using it for dynamic memory. When I say dynamic memory, it is very important because during execution, because heap memory is done during execution, during compile time, we don't know which data structure is taking how much size, how much memory it is taking. We might not have idea. So that's why heap memory is done during execution. We will do memory allocation and reallocation. That's why heap is dynamic memory. Okay, and how we are going to do all these things is by using two things, that is malloc and free. These are the C programs. These are the functions for allocation and deallocation in C language. So I hope you understand. In the previous slide in stack, we are storing the things in the compile time, the basic things like local variables, function calls, information, etc. When it comes to heap, we are storing the dynamic memory allocation and deallocation. It happens during the execution of the process. And also in the diagram, you can see two arrows because we don't know how much space is required. It just says, the arrow just says it is not a fixed size. Moving ahead, let's understand what is data. The data section stores unchanging information like global variables, constants, etc. In stack, we are storing local variables. In data, we are storing the global variables, which are constant, which cannot be changed until the process is terminated. We are not changing anything. So that unchanged content is stored in data. The next section we have is text section. The text section is very important because the code will be present here, the code part. Here it is not the code you wrote, it is the machine code instructions. It is not the high level program that you have wrote. So this is machine code instruction that is present in read only format. So it contains the code, it contains the instructions that is followed by CPU to complete the program, to complete the execution. So this is how in memory process is stored. Now, giving you a small recap of everything that we have learned in this video, because we have learned of many new terms, right? So put it in simple terms, when we write our computer programs in a text file and when we execute this program, it becomes a process. When we execute this program, it becomes a process. So this process, when executed, performs the task mentioned inside the program. Now, when a program is loaded into the memory, becomes a process. Inside the memory, when we say it is loaded into the memory, it is divided into four sections: stack, heap, text, and data. For example, if you have two instances of a program running as separate processes, if you are opening multiple notepads, multiple Word files, multiple PPT files, both of them have their own stack, own heap, data section is separate, text section is separate, everything is separate. So each process runs independently and works independently. So that's it from my side. Thank you so much for watching till the end. Please make sure you like, share, and subscribe to our channel. Get Play soon. In case if you have any doubt, feel free to comment below. I always be there to help you out. Thank you so much. Bye bye.